Anyway, hey guys, been a while. I know it ain't a lot of followers out there, but just been super busy and ain't really had time for YouTube for whatever reason. Anyway, I got a new project. I've got a new shop built out in my backyard. I call it my TV shop because basically it's a radio and TV shop. It's basically I want to work on old stuff. Anyway, I have in front of me, let me turn around here, an Atwater Kent Model 708. Now I've got it partially disassembled before I realized that I was going to actually work on or video this. That's the cover right there. Really not bad. Got a little swell right here. It's got some of the veneers coming off. I'll back up. The veneer coming off, it came off right here. I think I can fix that pretty easy. Got a little chips right here. I'm not sure that's worth repairing. Really, the cabinet's not bad. The front's really good. It's got a little spot right here. I don't know. I might be able to recreate that. I'm going to try to do it. This would be a pretty advanced, but hey, it is what. Oh, and I got some damage right here on the trim. I should be able to fix that. This is going to be very advanced for me. I don't normally get this deep into these things. This is the back. I pulled the chassis out. This is the cloth. It's real pretty cloth. I hope I can find something like that. This is the back. It's messy in here. I haven't cleaned it up yet. I think really this is salvageable. Here's the radio itself. Speaker, loudspeaker, is more or less intact. It's got this hole here and a couple of holes here. What worries me is it does not move. I think, I've never worked on nothing this old before, but I think I could take these screws off right here and take this screw off and this whole thing come out, and I should be able to clean this spider up. I don't know. Never worked on one of these. Tuning capacitors seem to work. Everything seems to move like it should, so that's good. It's pretty nasty. Let me see if I can turn this around without major conflict. The chassis is not missing nothing on the outside. It's all really dirty, but as you can see, this is a foreboding thing here. I'll see. This is the line cord and all this right here. See if I can pick this up without having an old crap on it. As you can see, got some little issues here. Since I've never worked on nothing this old, I don't really know what that is right there in that rectangular box. I think that's capacitors. I'm not sure. Don't know. Some stuff, all stuff going on right there. I don't know. The power transformer leads, you see the red ones, if you can see it in this light, they're pretty bad. So I think tomorrow after church I'm going to inspect the power transformer, and I'm going to check the output transformer, the power transformer. They see the output transformer, like I said, the output transformer, and then I'll check the cans, the IF cans, this one, make sure they're good, and go from there. So Atwater Kent 708, circa 1933. I've been wanting to work on older stuff, and I got one. So anyway, stay tuned. Alright, here we go, part two of the Atwater Kent evaluation test, whatever. First part, we just kind of looked at it, seeing what it was, what it looked like. you know, just a kind of a basic look around. This morning, get my coffee. Anyway, this morning we want to evaluate the power transformer. I've never worked on anything this old, so basically I'm going to do an ohm test. I've printed the schematic out right here. Now, I'm surprised how well this is built. The band select on this thing. You've got your input stages from your antenna tuning is selected with the band switch, and also the apparently the oscillator and front end section is tuned with this as well. It kind of reminds me of the band pass switches in a ham radio HF receiver transmitter. Well, that's pretty cool. I'm impressed. So anyway, before I do anything else to this thing, I'm going to ohm out the power transformer and probably disconnect it, and if everything ohms out good, I'll probably just go ahead and cut it loose from where they're connected and put it on my variac, and probably put it on my dim bulb tester and my variac, and see if it's even producing voltage. So I'm thinking how we can do this here. Let me attempt to zoom you guys in just a little bit. See what I'm doing. Just move you over just a little bit where I can see the camera. You know. All right. So, tell you what. I have multitudes of meters here. Is that too bright? Apologize. Think you can see the dial. I hope you can. Anyway, we'll use my I'm going to use my triplet this morning. VOM meter, VOM as some people might call it. Put this on the R times 1 scale, zero it out, make sure it's working. So, power transformer leads come out right here. Here's the two reds. Let's see, here's some, really don't know what color that is. That looks like it must go with a rectifier tube, I guess. Don't know my way around these things. Brown rubber, that looks like the filament. So I need to pull the rectifier tube without tearing it up, which I'm liable to do. Just pull this. I think this is a 80 rectifier tube. Need to pull this tube so I can check the filament resistance of the power transformer. It says Philco on here. Old Philco tube. I guess it's an 80. I don't know. It's so nasty. I think it's an 80 according to the schematic. An 80. We'll just put it here out of harm's reach. Anyway, let's see. Let's ohm. I believe there are two brown wires. Manual says here brown rubber. It doesn't give any resistance readings. That could be the primary. I'm getting a slight resistance there. That may not be the one I'm looking for. I don't think it is. No, that's the primary. That's something else we need to check. I think this must be the secondary. Yes, here we go. I've got a secondary resistance, it's almost 0 ohms. Then this is a 5-volt circuit, I would think. So it's going to be pretty low. Let me get my glasses on, I can't read this. It says here 500 ohms, 2 green wires. I guess that's green. Let's put this on times 10 scale. Supposed to be 500 ohms primary. I'm sorry, secondary. So it should be 500 ohms across the whole secondary. So let's see. 50 times 10 is 100. I don't know if y'all can see that. Yep. So we have a good secondary. Secondary is good. Primary, the filament for the 80 rectifier. Think that's good. Alright. So that's the biggest thing. Now I got two red wires, which are these guys. These are the filaments. I am just going to cut these poor souls right there. And see if we can get an ohmmeter reading on them. I'm just going to kind of touch. Yep, just about 0 ohms. I could get my DMM out, but I'm not really worried about. I've never seen a secondary filament circuit short. Usually, it's going to short. It's going to be the primary, and it's also, if there's the other problem that you would have to look out for, is the secondary of the high voltage being open. Usually, the primary is short on these transformers most of the time. So let's see. Here's, speaking of primary, here's the primary. Here's one lead. This goes over to the on and off switch. Alright, so I should have 5.6 ohms. So let me put this back on R times 1. Reset our meter. Alright, so I got two browns. One comes straight from the line cord right here. So what I'm going to do, I'm just going to clip that. Let me get my strippers. Alright, let's see if we can do this without a majority of damage. This wiring on this radio is all rotten. Every bit of it. Every bit of it's going to have to be replaced. Which is going to be a job in itself. Alright, let's check the primary. I think that's the ON/OFF switch. I'm not sure. Yep, there's the ON/OFF switch there. Okay. As I said, I've never worked on one of these before. Anyway, nothing there. Don't have anything on that. No resistance. Could be. This is the primary here. That's a capacitor. There we go. The switch is bad. I have resistance on the primary. Right there. And let's see, I'm on about 5, 6, 7, 7.5 ohms. It calls for about, I can't read that, 9.6. I can't read it, but alright. So that's good. So let's set this thing up. Let me move this out of the way just a second. Plug in my dim ball tester. Okay, turn that to 0. Let me get my cheater cord. Get these glasses out of the way. That's good. That's good news so far. What I'm going to do is I'm going to power up the primary. And I'm going to measure the AC. Let me change these leads here. And I'm going to check the output. I'm going to do this very carefully because I don't know what the insulation is like inside that transformer as far as all these leads. It's probably alright ones that I've ever cracked open before that had leads like this, they usually, as soon as you get inside the transformer case, they're usually pretty clean. So anyway, I'm going to measure the primary, I'm sorry, high voltage secondary first. I'm going to make sure that we're good there. I'm just measuring across the main secondary if that lead will stay put. So I'm going to switch you to the other side. Get all this stuff out of the way, and all the stuff want to cling around and stuff. I'm going to raise you up a little bit. See if we can pan out a little bit here. That's what I'm looking for. Alright, let me see here. Alright, there's my dim bulb tester right there. This is my Syncor AC Power Right variable oscillation transformer and safety analyzer. I can measure AC line in, AC line out. Current levels 0 to 1.5 amps, which is 175 watts, or go up to the 4 amp scale, which is 470 watts. Then this is the leakage detector. This is my voltage, variable voltage control. The output's right here. This is my on switch. We're turning it on. Tell you what, let's move this over where y'all guys can see if anybody's interested. Here. The gamma's not quite right on this. Turn the bench light off. Oh yeah, you can see a lot better. Okay, here we go. Oh, voltmeter popped off, of course. Alright, here we go. I'm going to raise it up slowly. So far so good. Alright, I'm raising it up. I have no current draw. I'm at 30 volts on the primary. As you can see, I have an indication here on the high voltage secondary. I'm on the 1000 volt scale, so I have 200 volts so far. We'll come up to 40. So far so good. And I'm thinking about maybe letting it run like this a little while. There's no telling how much moisture is inside this thing. I might put a load on one of the secondaries, the filament secondaries, to give it a little load. Anyway, I am at 60 volts on the primary. On the 1000 volt scale, I have about 380. So far so good. 70. A little over 400. How much does this thing have on the secondary? I'm just going to run it up here to line voltage. Wow, I've got 720. Am I reading this right? Yeah, 720 volts. 720 volts on the high voltage secondary at line voltage. Wow, that's pretty good. So I'm going to turn this off. Now I'm going to switch my meter leads over to the heater filaments. If I can get that lead off there. The reason I'm doing this, let me switch this down to 10 volts. The reason I'm checking this transformer out is kind of logical. If you're going to spend a lot of time and effort working on a radio to rebuild it, you need to at least find out if the main irreplaceable component is good, because if it's not good, there's no point going any further until you might be able to find another transformer somewhere that would work. And there's places out there you could probably find them, but I'm sure it's going to be hard to find and expensive. So here we go. I'm going to check the two filaments heater circuits, which being I don't know what these tubes run at because I've never worked on one this old. I'm just going to run it up and see what the filament voltage does. I'm coming up. I've got output. I'm just going to keep it up here at 120. I'm reading on the 10 volt scale. I'm reading shy of 3 volts. And I have no clue. I have no clue what that heater voltage should be. Let me get my glasses back on. This is a learning experience for me, so don't hurt me too bad. The dial light says 2.6, and we were getting, my old memory, we're getting about 2.8. So I suppose that's good. Great. So we got high voltage secondary, good. Our resistance is checked good on that. We got proper high voltage out. Our tube filaments are right. So let's go over here to the filaments of the rectifier. Again, I don't know exactly what it should be, but together we'll figure it out. And if anybody's here that's worked on these things their whole life, and cut me some slack, Jack. I'm learning. I'm used to 6.3 filaments and All-American 5s and all that stuff. I ain't worked on nothing this old. So anyway, here we go. Check the high voltage rectifier filament. Alright. I'm thinking that should be 5. Yeah. Almost 6 volts. 5.6. These sets are not designed to run off the 117, I guess. Anyway, so far so good. Let's see here. Here's the transformer. Get that in view. Primary, if you can see it right here. That checked good because wouldn't be getting nothing on the output. The way I'm not drawing any current. Here is the high voltage secondary right here. We were getting what, close to 800 volts. Here is the rectifier, which we just checked, the rectifier filament, so we're getting close to 6 volts there, so that's good. And then these two red wires right here, we were getting just shy of 3 volts AC, and that is what this thing is supposed to do. So thank the good Lord above, we have a good filament. I mean, we have a good power transformer. Yay! So I'm going to shut this down a minute, and I'm going to do some research, and we're going to check the speaker. They're going to check the speaker, see if it's continuity in the voice coil, and then the primary of the transformer, and then the so-called fill coil. And then once we do that, we'll check the transformers. So I got to research this, so it won't be a long prodding on video. I need to research and know what the heck I'm, at least think I'm know what I'm talking about. So I'll see you in a bit. Bye. Hey, ladies and gentlemen, here I am back again. Sorry to keep you waiting. I need my glasses. Getting old sucks. And drinking my favorite brew this morning on my favorite cup, Gulf Mobile and Ohio Railroad. I bought this at a flea market somewhere in Mississippi. I don't know if this is authentic or not, but I love this cup. It's got the gold rim around it. And coffee tastes just fine out of it. So, good stuff. Love my coffee. Alright. If you can see this, this is the, apparently the output transformer that takes the, I think this is probably a 2A5, I believe that would be the output. They're calling the second AF. Okay. Anyway, a 2A5 output tube, which is a high impedance on the primary, and you have to convert it to a low impedance for the speaker. So you have to have a transformer, which means transform. It transforms. What does it transform? It transforms the high resistance of this output tube circuit to the low resistance of the speaker. So they use a transformer. It's just like outside your house, you have high voltage coming from your power station, going into the transformer on the pole, and converting it to 110 or 220, so you can run your lights and your television and your computers and everything without frying them. And then same thing. It's just transforming the high impedance of this tube, the output tube, to a low impedance. That's all that does. So we want to check. I'm not sure I want to do this. It usually scares the heck out of me. But let's see. I've had 2 radios. The last 2 I've worked on needed output transformers. But there's a way to figure out what you get the tube data of the tube, look at the plate resistance, what it looks like, and you take that plate resistance and you take your speaker impedance, and you can calculate, using that information, you can calculate what kind of transformer you need. But that's basically, though, if the tube is looking for a certain amount of current, it's looking for a certain amount of impedance, and you've got 8 ohms, usually you can just find a transformer that will work. You can get it fairly close, but if you get a transformer with the wrong impedance, like you get one with 5,000 ohms and a 8 ohm impedance compared to 10,000 and 8 ohm, you're not going to have a very matched stage, and it will probably cause the tube to draw too much current and not operate in its proper its class A1 region properly, and it won't sound right. Anyway, let's figure this out, guys. I wish y'all could see the schematic. First thing we're going to do, bring back we'll check what they call a Volts coil. Volts coil is what's connected to the cone. It's mechanically connected to the cone. It's a coil of wire connected to the cone, and the output of the transformer sends a small signal to that, creates a magnetic field in that Volts coil. It acts upon the magnetic field of the field coil, or in newer speakers, the permanent magnet. The magnetic field going through the coil interacts with the permanent field with the magnet of the field coil or permanent magnet, and it causes the speaker to move in and out. So we need to check the ohmage of the Volts coil. And basically what I like to do, I'll go to R times 1 on my meter, and right here, I don't know if you see it or not, probably not, there is the Volts coil tabs, and I'm just going to put my ohm meter on and touch it. And I don't know if you can hear it, but I can hear it making noise. That's good. If you scratch a voltmeter in R times volt ohm meter in R times 1, you scratch the leads of a speaker, you'll hear it. You'll see the resistance, of course, but I'm more worried about hearing it. If I hear it, I don't even care what the resistance is. I can hear it scratch. That's great. The secondary with the Volts coil side of this output this speaker is good, and we'll check the output transformer next. That is good. I can hear it even though it doesn't have a field. I can still hear audio. That's great. I thought this speaker was locked up. So let's figure out I've never seen an open secondary on an output transformer. It's always been primaries. Primaries are always the ones that are going to give you problems. So let's look at the schematic if we can see it again. Yeah, you know what? It'd be really cool if I had a pointer. Do like the big wigs on the YouTube. Oh boy, I wish I had a better camera. Anyway, let me see. Here's the speaker right here, and if you can see it, that's the Volts coil right there that I just checked. Volts coil connects to the secondary of this transformer. Right here, this little coil here is a humbucker, and they use that to cancel any AC residual that's in the power supply circuit, and that's just too advanced for me this early in the morning. Anyway, here's the primary right here. This connects to the output tube, so your output tube is over here somewhere. Anyway, here's your this connection right here, and this connection right here goes to your output tube. This comes from the power supply. Anyway, what I want to do is I'm just going to find this wire and this wire, and I'm going to check the primary of this. And what I'm going to do is I'm going to put my ohm meter on a higher voltage scale, and I'm just going to touch from the center. Either one of these wires will give me a resistance if this primary is good. If I don't get a reading on either one of these to this part, then this output transformer primary is open. So cross your fingers. Here we go. Here we go. I've unplugged. This is the plug, 3-pin plug. Hang on, let me get a better meter lead. Let me get a better meter lead. Something that's got a little bit bigger grab on it. Gotta have, if you're gonna have a shop like I do, or if you're doing this as a hobby, you got to have meter leads. Okay, here we go. Here we go. We're going to go to the center. Doesn't matter any polarity. I'm not hearing nothing, but I probably need to be on a higher level. I do have resistance. I'm not here. Good news, y'all. Y'all can't hear it probably, but touching right here, I can hear the speaker rattling, scratching, and I have resistance. Hooray! Thank the Lord. Primary of my output transformer is good. So I'm good. I feel a lot better now. The power transformer is alive. The output transformer is not open. The volts coil is good. That is what we're looking for. Awesome, awesome, awesome. Let's see. Let me calibrate my ohm meter. Let's see what the primary is measuring. Just for grins and wiggles, this old buddy of mine used to say. He probably still says it. I ain't talked to him forever. Let's see. I'm showing about 500 ohms. Not very. Let's see what this says. 525. That's pretty good. Now let's check. Let's check the field coil. The field coil is kind of important too. Field coil is going to have a little bit more resistance. I think about 2,000 or something like that. So the field coil is good. Great. That's great too. So good. The field coil is good. The primary of the transformer is good. The output transformer is good. The volts coil is good. The power transformer is good. Great. Very, very, very good news. So I'm going to shut you guys down again and for a minute, and I'm going to figure out how to check these transformers, which are this right here, right here, and right here. These are the interstage transformers. I'm going to do a little research on how to troubleshoot them. Not troubleshoot, but check them. And I'll get back. Alright, back. Don't know if I figured out much, but I'm back. Alright, paper time again. And I don't know how this is going to look on video. Anyway, I've got to find out, or I found out that right here, oh, that's terrible, isn't it? Let me adjust this a little bit more. There you go. So, we have 1, 2, 3, 4. 1, 2, 3, 4. If you can read this, if I was really good, I could just integrate this. But anyway, the inputs from the antenna line comes in here to the band switch. And then this right here, the band switch selects each set of input coils. So there's 1, 2, 3, 4. I don't know what the bands are on this thing. I know one of them is broadcast AM, and then the rest is probably shortwave of different kinds, police band back in the day and all that stuff. And anyway, so I'm going to have 1, 2, 3, 4 cans on the input, which I'm assuming is going to be these 4. And then you're going to have 4 cans right here for the oscillator stage, because as you change bands you change frequencies, so you got to change where the oscillator does its thing. So here's your inputs, here's your outputs, or your oscillator, and it does your oscillator, I would imagine probably the tune circuit between the RF input stage and your first detector. Anyway, I got to figure out where these are. I mean, I see them here, but I don't know who's who, because I don't have anything on the schematic telling me what's what. So let's figure it out. Let's see. Here's the band switch right here. It's 1, 2, 3 wafers. Oh, it's got some funky looking stuff on here. I'm seeing brown, white, red, yellow. Yeah, okay. Let's see if we can find something that... Yeah, here it is. This is probably it. I'm just going to check resistance. Just going to check resistance on them. I don't really care what they are. I'm just going to go in there and just check resistance in each one of them. I think I see the topology of this thing. I don't know what the resistance should be, but I'm going to just check the resistance of these things. Let me get my schematic out here. I'm just going to start on this coil. I've got whatever it is. I've got a resistance there. I'm just going to go to what I can get to easy. This coil here has nothing. Don't know what it is. Got one down here. Got a big blob of solder on it. I don't know. Should I bore you guys with me trying to figure out this stuff? How about I just check one? That way I hate a boring video, and I'm trying, some of my other videos are boring and dumb. So let's see. Zoom in a little bit. There we go. So here's something that I can get to. So I'm showing, let's hope my own meter is accurate. Showing about 111, 112 ohms there on this one here, and I'm going to assume that's going to be T1. I have a red and yellow. That, of course, that don't look. That looks like black and white. I have no idea what this stuff is. Yeah, here we go. Black and brown, and I have no idea. I don't know. Get a little more light. I've got a red, a yellow. Look like red, yellow, black. I don't know, guys. I see 1, 2, 3, 4, 5, 6, 7, 8 leads coming out of that. My goodness. That's got a lot of leads. That's got to be, as many leads as that is, that's going to be the oscillator and IF section right there. So that's going to be T5, 6, 7, or 8. So, with that in mind, that looks like a... This goes to a bunch of stuff right there. I've got a white wire going all over the place. That looks like probably secondaries, because I got whites tying to everything. So yes, white, chasing this white wire down. Yeah, if I follow the plate of 58, tube 58 right here. Where am I? There I am. A 58 right there, and I come up here to this band switch, come back down. See, that goes through this coil back out to the white wire. So being the plate's got to have plate voltage, it comes from this white wire, and this white wire is going everywhere in here. So that's going to be our B+. So that is the primary, and from white to white I have exactly 0 ohms. I go to the other side, goes to the black, I have 112 ohms. Okay, so with that being said, that's a black wire. Let's see if I can find a black. See a red, okay. Oh, I don't think that's what I'm looking for. It's got resistance on it, but I've got a white wire. Oh, I gotta figure this stuff out. Goes to C. Goes to C at the band switch. So A, B, C. Let me figure this out so I don't bore you guys to death. Alright, continuing. Going back here, I'm still learning, but I've got to look in a little closer to the schematic. Right here it says R2, R3, R4, and R5, and it says flexible. Okay, I got to looking. Let's fix this thing where we can see. Yeah, right there. Let's give ourselves a little bit of gain. Right here, this funny looking little dude here, that is one of those resistors. It is not just an ordinary piece of wire, so don't be cutting that out. That is apparently one of the resistors, R3, 4, or R3, 2, 3, 4, or 5, one of those two. And the other thing I noticed, I've got a group of white wires, I've got a group of red wires, I've got a group of yellow wires, I've got a group of blue wires, and I've got a group of black wires. And according to the schematic, all these are grouped into functions. So I got to noticing that there's actually there's a section A on the wafer switches, a section B on the wafer switches, section C on the wafer switches, a section D on the wafer switches. Let's see, I'm missing one. Section E on the wafer switches, and the section F. So that's A, B, C, D, E, F. So that's 3 wafer switches divided into 2. So each wafer side of the one wafer switch is divided into 2, which is doing 2 functions. If that makes any sense. Glad it does to somebody. Alright, well, with that information in mind, now I've got to go back in and just trace these wire colors and see if I can. This is going to be tedious. I ain't going to subject y'all to that. So back in a few minutes, or an hour, or days, or whatever. Hey guys, I use Power Director to do these videos because that's all I've ever used, but I haven't done a video in probably a couple of years, and frankly I've upgraded this program and I just really never used it, so I'm not super fluent in it. But to me, that's a rather clunky program. I think I want to find me something a little bit easier, that like in some of this video I was watching as I was previewing it, it had some stuff I wish I could have put notations in right there while I was in the edit mode, but I really wasn't that advanced, and it just wasn't easy to just say, hey, I was wrong about that. This component's supposed to do this, or that's supposed to do that. I didn't get to do that. This really taking up all my afternoon even to edit this, and it's beautiful outside. I need to get outside. I've been messing with this all day. But anywho, on this radio, I checked all the output transformer was good, the speaker was good, power transformer was good. All the band switching transformers were good. The oscillator coils, all that was good. The only thing that I forgot to check or overlooked was the IF cans. So it took me a little while to figure out which can was what, because I could not find any nomenclature or anything that told me which one was what transformer was, like T9, T10, T11, whatever. Anyway, I basically took the rest of this afternoon and mapped this thing. And in a next future video, I'm going to map this, make a diagram of this, to map and explain which transformers what tubes what, and it's because maybe that'll help somebody out there working on one of these things. Anyway, so far all the unobtainiums in this radio checked okay, which is good. And I just wanted to pass that on to you guys. I pulled all the tubes out of it. I haven't checked them yet. Some of the plate caps are kind of loose. I've got to be careful of that. I'm going to probably try to unsolder the loose ones and clean it up and re-glue it. Just had to have some kind of high temp silicone, epoxy. Anyway, that's a later thing. I'm not going to bore you guys with that, but anyway, I want this to be a halfway entertaining, and hopefully maybe somebody will pick up something out of it. And if y'all got some advice, I'm open to it. That's what this whole video is about. I'm not trying to tell somebody how to do this mess. I'm just kind of sharing my experience with this, and I welcome any input, positive input or anything like that. And I'll never be a big video channel. It's been a long time since I posted a video. Some of mine is pretty crappy, and some of them very amateurish. But hey, I'm an amateur. I'm not a professional videographer. I do want some simpler software to use that I can do editing with. Matter of fact, while I was trying to download from this camera, I just pulled the camera card out and plugged it into my computer card and on my computer, and it quit working. I wound up having to just plug it in put the camera card back in the camera and use the USB port to pull it all, because my ports quit working. Go figure. Anyway, I've carried on long enough. I hope you guys have a great day. I'm going to close this up, get this all buttoned up, put together, and I'm going to shoot it out here and see what sticks. Y'all have a wonderful day. May God bless you guys, and we'll talk to you later. Bye.